Hello friends, myself Professor Nalin Thakur. Today we will discuss about dispersion relation, group velocity and phase velocity for transverse oscillation of plasma in the case of applied magnetic field equal to 0 and permittivity does not equal to 0 for plasma. You know, Maxwell equation for plasma can be written like this: E dot K is electric field vector, K is wave vector, E dot K equal to 0, B dot K equal to 0, K cross E equal to omega into B. Omega is the cyclotron frequency of incident wave, K cross B equal to minus mu 0 epsilon omega into E. All four equations we have derived earlier. You can study my previous lecture. Okay, now you see this is wave vector K. In this direction wave can be propagated. B is the magnetic field, okay, of a wave. E is the electric field. Applied magnetic field equal to 0, but B and E, okay, these are the field of wave itself. E is perpendicular K and B is also perpendicular to K. Now from equation number 3 you can say here K cross E equal to omega B. Let me cross on both sides. Okay, K cross E equal to omega K cross B. Then it is also equal to like this: A cross B cross C, A cross B cross C, like this, equal to B A dot C, C A dot B, A B C, B A dot C, okay, B A dot C. So K dot E, K dot E, K dot E, okay, K dot E equal to, this is K dot E, okay, equal to 0, like this. Okay, so in this way we can say K dot E equal to 0 minus A dot B, okay, A dot B, A B C, this is like that. A dot B means K square, okay, so minus sign is this, A dot B K square into C, that means into E, like this. So minus E K square, this one is called left hand side. Okay, so this side will give us minus K square E equal to omega K cross B, but K cross B equal to again minus mu 0 epsilon omega into E. So let me write the value of this in equation. Okay, E and E can be cancelled out, okay, and this minus and minus become plus. So final value equal to K square equal to omega square mu 0 into E. Now our aim is to find out the value of mu 0 into E. So what we should do? Relative dielectric constant or relative permittivity equal to epsilon divided by epsilon 0, like this. So epsilon equal to epsilon 0 into R. So mu 0 into E equal to mu 0 epsilon R, multiplied both sides mu 0, like this. Okay, so mu 0 into E equal to mu 0 into E equal to epsilon R divided by C square. Why it is so C square? Because you know that C equal to 1 upon mu 0 square root of mu 0 epsilon 0. So C square equal to 1 upon mu 0 epsilon 0 and so on. So we have write the value of this from this equation. Okay, now let us see here. K square equal to omega square epsilon R C square. This equation reduced like this. Okay, this equation reduced like this. You can see mu 0 into E epsilon R C square. So we have value like this: K square omega square epsilon R and C square. Why it is so? We have placed the value of mu 0 into E equal to epsilon R divided by C square. This value can be placing here and simplified form will be here, like this. Okay, that means omega square by k square equal to c square divided by relative dielectric constant of plasma itself. This is again key point equation. Okay, now you can see here, this is plasma material. Okay, this is natural oscillation frequency of plasma to and fro motion of plasma particle can be represented by omega p. It is a plasma angular frequency. So this is one type of a dielectric slab of a plasma. Applied magnetic field equal to 0. Thus our wave is incident on this dielectric material plasma. Now question is whether the wave incident on this plasma will be penetrated through plasma or not. So it is very useful condition. You can say omega p is plasma frequency, omega is frequency of incident wave. From the dielectric theory, epsilon r equal to 1 minus omega p square divided by omega square. Please keep in your mind, relative dielectric constant of a wave of a plasma, relative dielectric constant of a plasma can be represented by 1 minus square of the plasma frequency divided by square of the angular incidence frequency of a wave. Okay, so place this value of epsilon r in here. Let me again say omega by k equal to phase velocity. d omega by dk can be represented by group velocity vg. Omega by k, it is vph, phase velocity of a plasma, and d omega by dk, it is called group velocity of a plasma. So in this way we can say here, write this value in equation k square omega slash v square 1 minus omega p square divided by omega square. From this equation, place this value of epsilon r. Okay, again k square c square comes here and multiply this here. Simplified form is like this: omega square equal to omega p square plus c square k square. And this equation is called dispersion relation clause for plasma for transverse oscillation. This equation can be say whether the wave will be propagated to plasma or not. You can see here, if the value of incident wave, frequency of incident wave is very greater than plasma natural frequency, okay, then denominator is maximum, this one is numerator very low, then this will be equal to 1. We can say wave can penetrate through plasma. Okay, so in this way we can write here. This one is dispersion relation. Again come to this relation. Omega by k equal to phase velocity. So omega square divided by k square equal to vph square equal to c square divided by epsilon r. Place the value of epsilon r. It is already given here. Please keep in your mind. Okay, so you should write here. Okay, so phase velocity equal to c, velocity of light, divided by, in bracket and square root of this 1 minus omega p square divided by omega square. This is phase velocity of a plasma wave. Phase velocity of a plasma wave. Okay, again twice omega d omega equal to c square twice k dk. Differentiate on both sides. Okay, so twice omega d omega by dk, c square into twice k. Again omega by k equal to v ph. Okay, so d omega by dk, it is called group velocity equal to c square, and k divided by omega equal to inverse of phase velocity. So vg equal to c square divided by ph. So in this way you can prove phase velocity multiplied by group velocity equal to c square, square of the velocity of a light. And group velocity can be written, you can place the value of phase velocity in this equation. Group velocity equal to c, in bracket 1 minus omega p square divided by omega square 1/2. So in this way you can get phase velocity and group velocity for transverse plasma oscillations. Okay. For transverse plasma wave, we can write phase velocity and group velocity. Also prove phase velocity dot group velocity equal to c square. Thank you very much.